This is number 11 in our Chapter 3 test review on page 181, where we're asked to factor the expression completely. So, as always, we're going to look first for a greatest common factor. There is not one. Second, we're going to look to see if this is a special case. Well, it's a binomial. The special cases we have to choose from are a difference of squares, difference of cubes, or sum of cubes. These are both perfect cubes. The cube root of 64 is 4, and the cube root of t cubed is t. So we can use our difference of cubes method, or sum of cubes method, to factor this binomial. We take the cube root of each to get the binomial. That would be t plus 4. And then we know that when we factor a sum or difference of cubes, we get a trinomial for the second part. We take the first term of our binomial and we square it. We take the last term of our binomial and we square it. Both of those will always be positive. We take the two terms of our binomial and we multiply them together and then give it the opposite sign. And that is our factored polynomial. Now in this particular instance, we can go further. Tricky. We can go further because this trinomial, I apologize. I was thinking that trinomial is a perfect square trinomial. Well, t squared is a perfect square. Its square root is t. 16 is a perfect square. Its square root is 4. But in order to be a perfect square trinomial, we must be able to take the square root of the first term times the square root of the last term and double it to get the middle term. Well, if we do that, in this case, we'd get 8t. That's not our middle term, positive or negative. So this is not factorable any further.